So let me admit the people to come in. Okay, fine. So let me switch on the code. Have to do some maximizations for the for my screen. Okay, admitting people. Just a moment. Okay. Okay, welcome. So I'm still in the process of preparing. We are not going to have our test at 3, but we're going to have it at maybe at 4. Okay, so we're going to have a short lecture on a new topic today, but to make sure that the file is uploaded properly. Okay, part 7. We're looking at part 7, right? Okay. Okay. So for your information, we have finished the lecture on part 7, but I have uploaded a new set of materials in part 7 as well. But unfortunately, the file has not been updated yet. Just wait for a moment. Anyone want to ask anything before we conduct our lecture? Okay. Preparing for the session. So we're going to have a test, okay, today. Activity, we're going to have a assignment, which is going to be a test. So I'm trying to link the test questions to the Moodle web page for the moment. Okay. Okay, so we're going to have a test. Now I'll get you to do the attendance later, okay? Assignment. Let's see this. It's looking. Assessment. This is a test. Okay, so this is a test. No, it's not here. Okay, there are too many things on my laptop. Let me close all the windows first. Okay, today we are going to talk about part 7, which is on stochastic integration. So the notes is supposed to be uploaded online, but I think the problem is that it is still not yet been updated. The file, I think, take a few minutes to update the file. So I replace the file with a new one, but I think it is not really working at the moment. So never mind, I think we can still continue. People are still coming in, so we will not begin our lecture until everyone is here, okay? Okay, so if you go to the Moodle webpage, if you go to the Moodle webpage, think you can click on the lecture notes part 7. Okay, so this is the lecture notes part 7, but due to the lag in the MB viewer, which is not updating, so you won't see the content that is on my screen. Now what we're going to do at 3 o'clock here now is to talk something simple on what we call a stochastic integration. Now your notes will be updated only maybe a few minutes later. But I think you can still working on and try to understand the code here. So maybe within 15 minutes or so, only then the MB viewer will update the notes. Okay, so when it's updated, then you can download and then you can use the template to run your code. Now, we are going to have our test only at 4 o'clock. You have 1 hour. So that we don't waste our time. I think we are a little bit behind. Many classes has been missed. Many sessions has been missed due to many events, due to many things that happen. Okay. So before I begin on, just make sure that everyone is here and you are you okay with me? I can't see all of you. Only 29 of you are present at the moment. We have about 34, 35. Okay, I think some of them are missing. Now, those people who can't make it for the test will be considered as absent unless you have some good reasons. Okay. Should we still waiting? Okay, maybe we should wait for another 2 minutes for people to come in. So meanwhile, I'll let you to sign in your attendance. Just a moment. Part 7, Jupiter. This one, okay. Okay, here is your attendance. Okay, I think the attendance is taking a long time to show up. This one. Okay, could you please take your attendance? I'll give you about 1 minute or so. Okay, so if you cannot take the attendance in time, I will show the code again, maybe later. But at the moment, I would like to go to my Google Drive first. Google Drive, where is my Google Drive? Okay, so maybe I should open my Google Drive. Yeah. So I'm going to get the link for the test questions. Okay, the notes has not been updated yet. Let me check again. Okay, I think this is faster. Okay, I need to copy the link. I think this is a question that we're going to have test. Okay. So let me copy the link first. Then I'll go to the web page here. So this is test 1. Okay, test 1. And this is a link which we're going to have. And okay, so today 5. So we're going to finish it at 5 o'clock, maybe 5:15. Okay, and then you cannot do any submissions after that. 17 after 15 minutes, then it's done. Okay, so you're not supposed to see it yet. Okay, so I'm going to hide it. Okay, so is the link. Okay, fine. So we are going to have a test in a minute, but at the moment we are going to look at a new topics on stochastic integrations. Okay, stochastic integration part 7. Okay, now so you wouldn't have the test questions at the moment. You don't have the notes with you at the moment because I think it is still in the process of updating. Okay, so I have transferred the notes already, part 7, into the Anicca server. Okay, now this is what I'm going to show you. Today we're going to talk about a little bit on stochastic integrations. The stochastic integration is very simple. We are still on the process of learning the integration. Okay, let me take out where is my notes. Okay, I'm sorry that I sometimes get confused because I have too many notes in on my laptop. Okay, here it is. So here it is. Anyone want to say anything to me? Okay, now for the latecomers, we have not begun our lecture yet. So you're not too late. So I'll let you to do the attendance in a minute. So what we're going to do today is to talk a new simple topic. Maybe half an hour we'll be able to finish this. It's about stochastic integration. Now, for example, if you have a function, like we are still on the integration, let us consider a integration for a continuous functions. This is an example. So let me make it larger a little bit. Now, let's say you have a function that looks like this. You want to integrate a function called fz. It's a function of x integrate, say, from -5 to 5. So those blue dots are the area where you want to integrate. Okay, so the total area of this actually can be integrated using a method called stochastic integration. So if you want to know what is the area under the curve, which is represented by these blue dots, you can integrate it very easy, right? So you can integrate from -5 to 5 using, say, SciSpi. Very simple function could be used that we learn, integrate. I think this is the method that you learn. If you want to integrate a function, you just use this SciSpi integrate. So you define a function of f, then you say, well, this is, say, -5 and 5. Then you integrate it. Then you just define your function. Say you define this is your function. Say this is a function which is just exactly as this one. Now, if you were to do this integration, you wouldn't really get the total area under the curve. Right? What you get is a difference between the area, right? Because the area on the left-hand side, which is on the negative part, has a negative value when you integrate from, say, -5 to somewhere here. And then this part of the function would be positive, right? So when you integrate over, you won't get the total area. If you want to set the total area, the area on this part should be positive. The area on this part should be also positive. So integrate from -5 to 5 does not really give you the total area, which is represented by the blue dots, but it only gives you the difference between the area. Okay, so what happens if you want to know the total area between, which is the sum of this area plus the sum of this area? So performing the integration from -5 to 5 would not give you the sum of the area, but only give you the difference, okay? Because there are areas which are like positive, which is lying above the x-axis, and also there are areas which is lying below the x-axis. Well, now if you want to calculate the total area under the curve, you can do a very simple stochastic method. Stochastic method means now stochastic method is a very important method in computational physics, where you use random number to help you solve problem. So in this case, we're going to shoot many random number, and then we are going to count those points represented by these random numbers, which is lying inside the area of interest. So the concept to perform the stochastic integration is very easy. Now our purpose is to know the area which is enclosed between the curve and the x-axis. Okay, so this is our purpose. So how do you do this? Very simple. You just simply generate a random point, right? So a random point on the xy plane is represented by an x coordinate and a y coordinate. So you just generate two random numbers. One random number represents the x coordinate, and then another random number represents the y coordinates of your functions. Then after you have generated that point, then you ask, right, by writing a Python if statements, whether the coordinate of the random point is lying in the area of interest. So if, let's say, in this case, all the points that is blue color are all lying within the area of interest, if you generate a point which is lying outside the area, which is represented by this red color point, then this red color point represent random points which are lying outside the area, right? So you can generate many random points, pairs of random points actually. Then you would count the total numbers of random point that is lying inside the area. Then the ratio of the point lying inside the area, which is the total numbers of blue dot divided by total numbers of dot that is enclosed in this square bracket, multiplied by the size of the square bracket. Then that will give you an estimate of the area under the curve which is being considered. Okay, so you get me? Okay, so this is kind of simple. So the method to do this integration is summarized by a set of algorithms, which is I'm going to show it here. Now let me check to see whether the MB viewer has already updated the files. If already updated, then you can view it. Still not yet updated. I'm not sure what happened. Okay, so it's not yet updated. It takes some time to update. Okay, never mind. Just try to follow the argument first. Okay, so what you do is, first of all, you have to decide what is the x minimum and x maximum of your integration. That is the range of integration, lower limit and upper limit of x. So in this case, I choose, say, x to be minus 5, and then x equals to 5 on the right hand side. So we are trying to calculate from minus 5 to 5, and this is a very complicated, well, this is not really a complicated function. It's a function of x plus 1 divided by x squared, z squared plus x plus 1 squared raised to the power of 2 over 3. So we are going to do this integration. So you can actually print out this function very easily. You can print out this function quite easily, but be reminded that this function has an extra parameter, which is z. So z is the number that is here. So when you have a z, then that means the function will be shifted along the z direction, along the x coordinate. But doesn't matter. In this case, your z is just a number, which is just 1. Okay, so you can slot in 1 to z, and then you can plot these functions, and this function will look like this. Okay, so you have to decide if you want to know the area under the curve represented by blue dots. You have to know what is your left-hand limit, right-hand limit of x. So in this case, the x is minus 5 to 5. Okay, so in this case, I define my x last to be minus 5. X last is 5, and x init is the left-hand limit, minus 5 to 5. Then you have to decide what is the size of the box. So you see, this is a box. It's called a rectangular box. So the rectangular box has a height. Right, so this is a height. So roughly speaking, the height is, say, from minus 4 to plus 4. Okay, so you have a minus 4 to plus 4, which is the height of the box. So what is the total area of the box? The total area of the box is very easy, right? The total area of the box is just the length of the box times the height of the box. So you have to decide what is the length of the box. So the length of the box is just the x max minus x min. And then the height of the box here is estimated to be minus 4 to plus 4. But roughly, you can actually do a very simple estimations. So if you already decided what is your x min, x init, and x last, then you can use a very simple function called max function or min function in Python to decide for you what are the maximum values of the function f within the range of x. So x range run from minus 5 to 5, and you know what is the function. The function is this. Then you can try to estimate what is the minimum values of the functions of f from -5 to, when x is from -5 to 5. So basically we want to locate this minimum point of the function f and the maximum point of the function f. So in that case, then the height is just a y maximum minus the y minimum, right? So if you can locate the y max and y min, then the height of the box could be just given by y max over y min. So by doing that, initially you set your x init, x last, then you estimate what is the maximum and minimum of the y functions, then you calculate the area of the box. After that, you just do this, right? So you choose a number. Say the number NP is very large, say 1,000, 2,000, 5,000. NP is the total numbers of points to be generated. So you have a red color point, blue color point. So the total numbers of points is just the NP. Right? Some of the point will be falling in the area. Some of the point is falling outside the area. So you just have to write a code that would count. Wait, now I need people to come in. So you just have to admit or just count the numbers of points that is lying inside. So you have to write a if loop for that purpose. Okay, so let's just come back to here. So you choose a numbers of NP. Then you generate a random number called xran and yran, where xran is a random number that lies between x init and x last. Yran is the random number that lies between y minimum and y maximum. So by doing that, you will be able to generate a pair of coordinates. Right? So these coordinates could be anywhere. It could be lying on the left corner, right corner, lower corner, lower left corner, lower right corner, inside the area, outside the area. So this random point could appear anywhere uniformly. So you have to generate a random number which is uniform for this x line between x min, x max, and y min, y max. Okay. Then you have to do this. The important point is that you have to write a code to count if the pair of coordinate xran and yran lies between the functions and the x-axis, then you count. Right? So this number of count will be updated and increment by 1 if that point is lying within the area. If the random point is lying outside the area, then you don't count, right? So then you keep on doing that by generate many random points. After that, the total numbers or total area of the functions, or maybe this is something which is not right. Well, I would say like this. Then the total area of the functions, let me see, this should be the absolute values of f. Okay. The absolute values of f is then given by the numbers of count and p. Okay. So the area of the functions would then be just the numbers which represent the area of the box multiplied with the fractions between the numbers of points inside the area divided by total numbers of points. Okay, so the idea is very simple. So let us try to write the code. Right. So first of all, you have to make sure that you provide the initial condition first. So when you start off with these questions, you always know what your function is, and then you always know what is your x min and x max. So let us define the function x min and x max. So in this case, I define my function first. So this is a function, is a function of x, and then this z is an argument which is a constant, which is equals to 1. So I'll provide z equals to 1 into the function when I call the function. So this argument is just an extra parameter which I can pass into the definition of f. So this is a function that represents this form. Okay, so this is the function that I just defined. So when z is equal, sorry, I think here, when z equals to 1, then this is just equals to 1 now. So, but this is a whole function in terms of a z. So when I need z equals to 1, I just pass z equals to 1 into this argument. Okay, so I can choose my initial values of x and the last values of x. Okay, then I have to decide, then I have to generate points from x init, x last. So let us try to generate maybe 50 points, 100 points, doesn't matter. So let us generate 200 points, which represents the linear space. So this is just an array that represents the numbers of points that lies from here to here. Now my purpose is to evaluate the function of f for each of the x that is lying from here to here. So there will be 500 points to be evaluated. So for x from x init and x last, I choose 500 points separated evenly. For each point, I will calculate the values of the function of this point. Now, my purpose is to scan the values of the function for all values of x, and then I'll be able to generate the find out what is the f minimum and f maximum. Okay, so this is the purpose. So maybe let me try to reproduce these functions here. Okay, so let me copy part of it. Okay, so this is this. So let me do it here. Oh, sorry. What have I done? I've done some stupid thing. Control Z. Okay, I'm bad. I think I made some stupid mistakes by deleting the content, but I cannot undo it. But doesn't matter. Let me do some revisions. Okay, maybe I can. Okay. I'm sorry that I mistakenly delete my lecture notes, so I have to recall the lecture notes again. Okay, part 7. Let me download it again. Okay, fine. Okay, part 7 again. Okay, so we are still here. No, something has gone wrong. Part 7. Okay, so I think it's here. There's some functions that is missing, some graph that is missing. Okay, so let me upload the okay, so that will be fine. So let me close my file and open again. Hopefully then everything will be fine again. Okay, refresh, and then part 7. Okay, so now you can check out the notes on Angular Viewer. The file has been updated, so you can see the lecture notes as I'm showing on my screen. Okay, I think it's my notes has not been ready yet. Okay, sorry for the technical delay. Line is very slow here. Okay, it takes forever to upload the files. Part 7. Okay, I'm waiting for the transfer to complete, but it doesn't get complete for some reasons. Okay, while waiting for the file to transfer, maybe I'll just let you to do the attendance first. The attendance is here. Okay. Okay, never mind. I think we just continue from the previous case. Okay, so let me continue with the stochastic integrations. Now, once I have done that, I would like to plot and show the functions for X array, and then F argument X array with the argument Z equals to 1. So that should display the function that I want to see. So it looks like this. So maybe I should plot a horizontal line and a vertical line just to show the line of y, z equals to 0. So I just learned a new trick that I want to share with you. I think it is kind of convenient. In order to plot a line, a vertical line on the graph, what you need is just to show this line, okay? So you just say AXH line, and then this, I think is AXH line 0. This is to plot an horizontal line at x equals to 0. Then this is to plot a vertical line at 0. So I think this will give you the y-axis. This will give you the x-axis. So you plot it together, then you see the line, the x and y-axis is displayed. Okay, the x-axis and y-axis. Okay, so I've seen my graph, and then maybe I should Okay, so let us continue anyway. So the next thing what I want to do is this. If you look at the lecture notes, the next thing I want to do is to define my area of A, and then to find my y max and y min. So I'm going to find my x min and x max. So the function of f here is printed as x array with z. Right. So if I were to do that, then this will print me a values of z for all values of f from -5 to 5. So I think this will do it. Right. So this is a list of number that displays all the x values or all the y values of the function. So what is the lowest number? So it's here. What is the highest number? It's here. So this number has a mean. So you can actually calculate the mean of the functions. You say np.mean. So np.mean, when it takes in all the list of value for the function f, then it will give you the minimum value. Right, so this is the minimum value, which refers to the point of x, which is like, it's not exactly this number because the numbers of x is discrete, right? So it may miss the minimum, but this is at least the smallest number that you could have for the discrete values of x. So if you were to refine this to be, say, 500, then the locations of the minimum would be more accurate, right? So you can refine the intervals between the x by increasing this number. That will give you the minimum. Now likewise, you also can obtain the maximum. So you call this x, well, you call this y minimum, and then you call this y maximum. So this will easily allows you to locate the minimum and y maximum. Now this is a trick that could be useful in the future, because if you could, if you want to find the maximum and minimum from a list, that is how you do it, right? So you use max and min to do it. So here you see that the minimum is this number, minus 3.8, and the maximum is this number, which is this. So by doing that, we're able to get A. So what is the area? Area is y max minus y min, and then also multiply with x init. So, well, x last minus x init. So this will give you values of the area, right? So you can plot this, then you show that the total area is 7. No, not quite. Why is that so? Yeah, so it's about from -5 to 5, so it's 10. 10 times -4 to -4 roughly, so it's about 0.8. So 0.8 times 10 give you roughly this number. So this is correct. So that is how we do it, right? So then you have to learn how to then generate a random number. Now to generate a random number, you need to use this. Okay, you say random dot random. This will give you a random number which is lying between 0 to 1. But what you want is a random number that lies between, say, -5 to 5 and a y min and y max. So there's a very simple random function that you can use. We call this so x random and y random. So by doing that, you're able to generate a pair of random number. So I'll call it print x random, y random. So this will print out 2 random numbers which are generated randomly, which is uniformly distributed between x init and x last, y minimum and y maximum. So by doing that, you are able to print out a pair of random number, right? So x ran is a number that is picked from -5 to 5, and then the random number here, y ran, is picked from -0.4 to roughly 0.4. It's actually 0.28. Then you can try again. So every time you keep on running, you get a different values of the random number. Okay, so then we would put this random number in a loop. right? So we're going to have a loop that's going to generate many random numbers. So how many do you want? You say I, for I in range. So NP. NP is the numbers or point that you want to generate. So you have set the NP to be, say, for the beginning we just set 100 just for the sake of demonstrations. Then for each of these I, we would generate a pair of random number like this. So if I press a button, I'll see 100 point of random number that will be generated. So these are 100 points of coordinates. Okay, so each of these coordinate point will be tested for whether the function is lying inside or outside the function, inside or outside the area of interest. Okay, let's see if this is working now. The pictures is missing. The picture is missing because it takes forever to transfer the file. It's a very large file, 4 GB for the pictures to be shown there. Okay, so so let me continue. Part 7. Okay, so this is my part 7. So what I want to do is I want to check, right? So the functions looks something like this. I want to show you the function, but I cannot show you the function, is gone missing. Let me try again. Part 7. Okay, so let me try this. I should transfer this part 7 back, download, and then it should go to my hard disk. Okay, let's try again. Refresh. Part 7. Okay, so this is the part that I have mistakenly wiped off just now. So let me cut and paste this. Okay, so this is what I want to do. Okay, so I'm back. Oh, what happened? Okay, this is marked down. Okay, so I can show it now. So I have to test a functions. I have to test the point whether the function is lying inside the area or outside the area. Right? The area depends on whether the function is in the positive side or negative side. Now, if the function is in the positive side, a point that is lying inside the area could be determined by a very simple condition. That is, if you compare the y coordinates of the random number, if the coordinates of the random number is lying between the function f and x equals to 0 point, then it's inside. Whereas if the function is in the negative side, you compare the random values of y, and if it is larger than the values of the functions at that point, then only you count it. So what I'm trying to say is that the conditions to determine whether a point is inside the area depend on whether the functions is positive or negative. Okay, so the condition for the point inside this area and the condition for the point inside this area where the curve is in the negative region is different. So you have to be careful about this. Okay, so that is what I'm doing. So if you look at this, I have to check whether the function is positive or negative. If the function is positive, then you would consider the random number to be inside the area if this condition is fulfilled, right? So this is the values of the function evaluated at the random point of x rand. Right? See, when you do the stochastics, you generate a random number for x and the random numbers for y. Then you evaluate the values of the function f at the random number of x. Now, if these functions at x random is positive, that means you are talking about these situations, right? About these situations. If f at x random is negative, then you are talking about these situations. So if this is the case you are considering, then to determine whether a point is inside this area or not is logically decided by these very simple statements. That is, if the values of the y random is smaller than f but larger than 0, right? So this is a statement that says the random point is lying below the functions, where the function is positive at x random, but is lying above the y, lying above the y equals to 0 number. Okay, so in that case, if this is true, then you count the numbers of points. Then if the functions f evaluated at x random is negative, right? So this is the situations, right? So if you look at the structures of the if statements, if this function at x random is positive, then you do this. Else means f is not positive. It means else here means f is negative. So this is the conditions, this is the execution to be done if the function at x random is negative. So when you enter these else statements here, the values of f at random is considered as negative, right? So if the random number y rand is larger than the negative number of f evaluated at x rand, but y rand itself is also negative, then only you do the counting. Okay, so this is a very simple conditional loops that would decide whether a random point is inside the area or outside the area. Okay, so you generate a random point, you decide whether the function at that x rand is positive. If x is positive, then you compare the y random with the function at x random. Then you decide whether that random point is blue or is red. So it's in this case, if the random number y rand is negative but is larger than the function at x rand, where this function at x rand is negative also, then this is the point that is inside this area. So you can do that very simply by keep on changing the numbers. Then now what I do is here is that I would not only count the number, I would also try to store the number. So this is a new syntax that I have not taught you before. So what you do is that you initiate an array of the shape np2. Okay, so let me show you what is this inside. Now this inside is just like a container. It is an empty container. NP is a number. Okay, NP is 100. So if you ask the computer to print out what is this, it is just an array with the shape or dimensions of 100 times 2. Right? So it's a list of 100 row, where each row has 2 entries. These are empty entries. So what I do is that I first prepared an empty list which has NP row, which is 100 row, and each row has 2 entries. Then this inside is just like a container. So whenever the random number is lying inside the count or inside the area, then the coordinate of this pair of random number will be kept inside the container. So this is sort of like append, okay? So you just append it, but in this case, your append is to append in a V-stack manner. So you use these functions to stack this xren and yren into an array called inside. Well, you don't really need to understand it or memorize the details right now, but you can spend some time to try to understand what it means. Okay, so this is just like append, a pair of coordinate into a row manner. So VStack is just a new function that you learned today that will append. So if the pair is coordinate is inside the area, then it will be appended to this inside one by one. Okay, not all pair will be appended. Only those pair of coordinate that is lying inside the area will be appended. So there are two possibilities, this possibility or this possibility. So either one possibility would mean the random point is inside the area, then you keep that random point. Okay, so every time when a pair of coordinate is inside the area under the curve, then you increment the count by 1. Make sure that you also initiate the count to 0 in the beginning. So when you finish running the for loop from here for 100 point, finally when it exceeds the loop, I think here is the loop, right? So once you finish the loop, when you exit, what you get? You get count. Right? Count here would means the numbers of point that is lying inside the area. So let me try this. Let me press a button. Okay, so here it says to me, when I set my x and y to be -5 and 5, then my x mean is this and x max is this, and then my x last is this, x mean, then my area, then my count. Now there, out of total 5,000 count of NP, 981 is lying inside the area, and then the total area is this, right? So when I multiply it, when I multiply the area with the fractions of count over NP, I got this. Now this represents the total area of this plus this. But if you integrate the functions using SciSpi integrate, you're not going to get exact the same number. So when you integrate using SciSpi integrate, you get this number instead. Okay, so this is the difference between these two and two. If you want to obtain the total area, which is a positive number plus another positive number, then you should instead of integrating f, you should integrate the magnitude of f. Okay, so in that case, the f has to become an absolute values. So I'm not sure whether this is doable, but I never tried this before. But maybe let me try this. So if I make this to be np dot absolute like this, I think this will be the absolute value. I'm not sure, I never tried it before, but let me see this. If I have -1 np dot absolute, do I get 1? Yeah, so I think this is the function. So instead of calculating the function, I calculate the absolute values of f, so that when I press the button, this SciSpi integrate that calculate the absolute values of f should give me this number, or roughly equals to this number. I'm not sure, but let's try anyway. No, there's an error because I think you cannot integrate the absolute function here at this point. The f has to be remain here. So if you want to check the functions, maybe we have to do it some other way. Okay, so maybe not like this. Okay, so it is not possible at this moment to check whether the total area of this plus this is indeed correct. So the answer for this stochastic integration is taken to be 1.55. But this number is not really the sum of the area, but only the difference. Now, how do you know whether the answer is correct or not? No, it's very simple. You just have to calculate only the positive area. Right? So if, for example, when x is larger than 0, then the area is positive. So let me change this x init to 0. Okay, and then the y minimum is then taken to be just 0. So if I take this y minimum to be 0, it means that we only consider the area which is positive side, right? So the box size is from 0 to 5, and then the height is just from 0 to y max. So the y max is 0.35. So by doing that, we only calculate the area which is in the positive domain. So in that case, what I get is that the stochastic method gives me this number, which is 1,458 counts of point lying inside the area, and this is the total numbers of points I generate. Then the fractions multiplied with the area will give me this number. And then this is just the integrations of the function using SciPy integrate. And then you can compare that indeed, in this case, these two numbers agrees with each other. Okay, so that's all I want to, wait. Okay, so that's all I want to show you. Now, I do it very fast because the concept is very simple. Let me summarize it. To do this, to do the integration, you have to generate pairs of random number, and then you do the counting. So this is the condition for the counting, right? So you have to decide on whether the functions is positive or negative. If it's positive, then this is the condition to determine whether a random point is inside the area. And if the function is negative, then this is the conditions. Then you have to, in order to show the points, then you have to use this V stack to keep the values of random number. But this insight is actually optional. I define this insight as an array just to display the dot. Now, if you don't need to display the dot and you just want the numbers of n count, then you don't really need this insight. Okay, so it's a very simple exercise. Later on, I'll try to modify some of the corrections in this part of lecture notes. I think there's some error here and there. I just do it a few minutes ago. So I'm going to correct this and then update it to the online resource. Then you can take a look and practice on this stochastic method. And as an exercise, I'll give you a very simple 1 or 2 or 3 functions. Then you just integrate it. Then your integration have to be compared with the standard SciPy method. And make sure that the stochastic method turns out to be agree with the SciPy method. Okay, but another thing I want to mention is that the numbers of total points that you integrate, that you generate, here you said is 5,000. Now you find that if you choose numbers of NP to be less, then the method would not be accurate. In order to get a very accurate integrations, you have to increase the numbers to as much as possible. Maybe 5,000, maybe 10,000. So you increase the numbers of NP, will increase the accuracy of the stochastic integrations. Then last question is that why do you want to use this method? Because this method is actually slow, but is very powerful if you were to perform integrations of multiple variables. Right? For example, if you want to integrate a function not of one variable, but say 100 variables, then stochastic method would become more efficient than the integration using the area method, which is the SciPy method. So the stochastic integration in this example does not show very powerful application, but it will become very powerful if you are integrating, say, 4-dimensional, 5-dimensional, 6-dimensional functions. Okay, so anyway, I introduced this stochastic method here, as part of the integration chapter, because I need you to learn about the concept of stochastic method, right? So, and then to learn new syntax, that is this append, which I also learned it just a few minutes ago. So this is a way how you can append a pair of coordinates using VStack. Then you also learn how to use the new, I think today we learn another new method, which is random uniform. I think we have used it before maybe. And another thing that we learned today is, I think that's all. Okay, I think there's one more thing is about this H line. I think I like this. So it can plot a vertical line and a horizontal line by just specifying the values of the x coordinate and y coordinate of the line. Okay, so that is to fulfill the syllabus for these hours. We take a break. I think you would. We will have the test beginning soon at 4:10. I actually allow you to have more than 1 hour. Okay, so if you want to stay for another extra like 10 or 15 minutes after this, you're allowed to do that. Okay, so let's just come back at 4:10. Then we will have our test. Okay. Okay, so any questions at the moment? Okay, so it's 4:07. At 4:10 we'll begin our test. I'll show you a test, and let me explain to you also some of the questions of the test later. Okay, if we take a break now for a moment. Okay. Okay, so I have already opened up the test questions. Could you please go to the URL and then click on this test one. So you're supposed to be able to see the link now since I already opened it. So you go to this assignment test one. You click on it. You'll be able to see this page. Now I am changing to Google Drive and use a new, maybe a portal called Google Lab. So you have to click into Google Lab. Now, if you have problem accessing the Colab, you have to let me know. I have to give you extra times to do that. So there could be some problem with the Google Lab for those who do not have a Gmail. Now, for some reasons, the the IE web browser does not work very well for the Google Web. So you have to use other browser, say a Chrome or a Firefox. So this is the browser by the IE browser doesn't work. So you just have to open it using a Chrome or a Firefox. Okay, so it looks like this. Now, if you have problem to access the file, just let me know as soon as possible. I'll try to help you. Okay, so any questions? Anyone who have problem or accessing the files? Now, into this case, you have to have a Gmail. Okay, if you don't have a Gmail, you may have problem accessing the questions. Okay, so this is the test questions that looks like this. Okay. So we have a bit of time to explain. So you have to read through this, and then you have to download a file. Okay, so you have to download the files, and then you have to open the file using this script. So once you have downloaded the file, called time series COVID-19 confirm global case, then you execute this line. When you execute this, you're able to see the latest content of the file on your web page. So you go to this Google Colab and then download the file. Okay, you don't really need to see. You can download this. So let me repeat again. We have not really begun our lecture yet. Okay, so this is what you do. Okay, so you go to the link, then you can download this. Okay, you download the IP. Okay, so you download. I think you download. Yeah, so you download. I think there's some problem with this. So download. Well, anyway, when you open it, you go to this one, and then you can download it from here. So you can download this file into your laptop. File, save, or download IPYNB, right? So you do this, and then you just download it into your local laptop. Then you can start to do the questions. Now I'm waiting here. I give you extra time for you to download the script, the questions from Colab. Then you read the instructions carefully. I have done the first part of the question for you. So you just have this. Once you have downloaded the files in your local hard drive and you execute this, you will be able to see these are the data. Okay, so this is a set of data. Now we have not begun our test yet. Okay, I'm just explaining to you. Now once you have opened the data file, then this is the data file that you could open. So it's an Excel file. Now if you have downloaded this file from the internet, in the link, you open this file. So this is a file that contains all the data. Okay, so for example, you go to this data for, say, let's say Finland, right? So this is the numbers of COVID cases on the first day. Maybe here, I think Afghanistan, maybe Algeria, okay, Argentina here. So on the January of 22nd, there's 0 case of Argentina in the COVID virus. So these are the numbers of cases for the Argentina on the date that's specified here. Okay, so what you need to do for this test is to, let me see. Okay, so your job, it's difficult. No, it's a bit slow there. Assessment, yeah. Okay, so your job is to solve task 1, task 2, and task 3, right? Task 3 and then task 2. Now, these are the sample code that are expected from you. So your job is just to first print out the accumulated cases as a function of day for Malaysia. Then you are supposed to grab the other 3 countries and print out. But you don't simply grab the function, you have to look at your matrix number, right? So you read the instruction carefully. So if your matrix number is, say, 939, then you have to grab these 3 countries, right? So the instruction is there, so that I have not given you you don't need to begin the answering question yet. I just want to provide the instructions carefully first, okay? So I want you to pick the specific 3 countries based on your matrix number, so that when you submit your assignment, you must not copy from your friends. If you copy the codes from your friends, then you would print out the wrong number. Okay, so you have to print out. You would have accessed the wrong country. So you pick your country based on your matrix number, and then you print it out. So you take about maybe 15 minutes or 5 minutes to do task 1 and task 2. Task 3 is a bit difficult. Task 3 is quite a challenging one. You are going to fit the data of the last country. Say, for example, the last country here is Indonesia. So you take the Indonesian data, and then you extract the last 7-day data for the Indonesia. Then the numbers of cases for Indonesia for the last 7 days have to be fitted on these functions. You have to find out what is the best values for T and what is the best value for K. So that is the task 3. Then you plot the fitted functions and overlap it onto the original data, and then report what is the best fit values for A and K. And task 4 is just a number. So if you can answer task 4, then answer. But this is just an extra marks. Will be given to you if you can answer this correctly. Okay. So now I'll let you to begin the test. I'll wait for you for 1 hour plus maybe 10 more minutes. So you can begin it now. I'll allow you to submit the test within, I think I'll submit the test at 5:25. Okay. So let me go to this assignment test 1, edit it. So you will be allowed to submit at 5:50. Yeah, so you have until 5:50 to submit your solutions. Okay. Now, any questions, you can just either message me or just ask me here. It's very quiet, so I'm not sure what problem you have now. Okay. Until 5:30. Okay, so you can begin now. 445, no, you just, if it's 445, then you check again. I'm sorry to interrupt for a while. I just discovered a small typo mistakes in your task 4. I think I removed the word Malaysia. So the question now asks how many days will the cases double in size? So the word Malaysia has been removed. I think it was a mistake. Okay, so nothing very special here, just to answer these questions.